Alright, 9.2 is dealing with an arithmetic sequence. We just came off of a study of sequences and series, and what we needed to really do is get used to the notation of these sequences and series and what they were asking. Now what we're going to do is just focus on a certain type of sequence that holds a certain pattern. So our objectives here are to recognize that pattern those patterns that are arithmetic. We're going to continue using those notations and then also understand the key elements of an arithmetic sequence. So this is a warm-up. This is actually kind of based off of one of the problems that you had in your last homework set by asking you to come up with an equation and then find a sub 100 of the sequence. If I gave you this down here, what you could identify this as is recursive. And then what do we really want to do with it? Well, I want you to come up with an equation and then therefore find this a sub 100. Now why would we want to come up with an equation? Well, because a recursive would have me doing 100 steps, right? In order to get a sub 2, I would have to use a sub 1. That's what this is saying right here. To get the next term, you would have to use the previous minus 4. So I could very well say, well, a sub 2 is 28 minus 4. And then a sub 3 is going to be this number minus 4, so 20. But can we, once we start to recognize, hey, this is my sequence, can we come up with a way of getting the nth term, so like the 100th term, such that I don't have to generate all 100 of these terms? So this is when a lot of your eyes are being open to the fact that this is just linear. If I were to plot these points, there's my 1, 28, here's my 2, 24. If we were to plot that, that's just forming a line. So if I wanted to go all the way to down the line to the 100th term, I should be able to do that using a line. So here is your vocabulary. From now on, what we want to understand is that an arithmetic sequence is a sequence that takes on a common difference. From one term to the next, you're subtracting or you're adding a certain amount. So to find that change, well, you're going to have to take new minus the old, a more recent value minus the previous value to get that difference from one to the next. So determine if these sequences are arithmetic. Well, I'm going to go ahead and then take this 7 minus 4. So what would it be? 7 minus 4, this is going to be 3. 10 minus 7, so 10 minus 7, and again, I'm just fulfilling this right now. I'm saying take a value, subtract what's on the left of it, and then that's going to be my difference. So here, I'm also going to get 3. From here to here, what was the change? This is going to also be 3. So yes, this is arithmetic, and then the common difference would have been 3. Okay. So here, let's go ahead and see. I can see that there's a pattern. I could even tell you the next one in the line, but let's see, is this arithmetic? So 40 minus 80, so 40 minus 80, that's going to get us negative 40. And then here, 20 minus 40, that's going to get us negative 20. Right there I can stop and say, no, this is not arithmetic. So now, this is coming up with that explicit equation, or just an equation for the nth term, right? That explicit equation is just coming up with an equation so that you can plug in the nth term. So this will generate, you did have this vocab in the last video. So arithmetic explicit equation, what I'm going to have you do is use this right here. You're going to need your D. D is just that difference that you're going to calculate. And then the C is what we've also been used to as the y-intercept. And how do you get that? Well, you're going to have to take your first term minus whatever your difference is. I'd like you to consider why that is. We'll discuss tomorrow. But if I wanted the explicit equation for this, I'm going to say a sub n is equal to, so here to there, I'm asking myself, 4 plus what is equal to 7? 7 plus what is equal to 10? Well, what we found was that 4 plus what is equal to 7. That was that common difference, right? I would just be doing that 7 minus 4. That's going to get me that common difference that's happening from one term to the next. So we're adding 3 each time. So I'm going to fill that in. 3n plus, that c would be the y-intercept. I'm asking you to go one place back to a sub 0, and I'm going to be saying what would it have been there? Well, we're going to have to take that 4, that's my a sub 1, minus the 3, that's going to get me 1. There we have it. Try to think of why that works again. Okay, kind of explain to me in your, be able to explain that to me in your own words. Here is your assignment that we'll be working on, and again you'll have a worksheet that's going to be doing an exploration of finding an arithmetic series or adding those sequences up.